Hey class, today's lesson is on inverse functions. If you want to go to the Common Core standards, here's the standards for inverse functions. So, I have a couple of learning goals and objectives. What is an inverse function? And when does a function have an inverse? And if that function does have an inverse, how do you take the inverse of that function? You should be able to answer these and do these at the end of this lesson. A function has an inverse if that function is one-to-one. So we did one-to-one a couple of class periods ago, so here's a quick review. A function is one-to-one if and only if there's a unique x value for each y value. We use the horizontal line to test this. So let's just go over a couple of examples real quick. The first one is y equals x squared. So we see that this is not one-to-one because anywhere that you put a horizontal line above the x-axis, it will touch in more than one spot. Y equals x cubed is one-to-one, and y equals 1 over x is also one-to-one. Notice the domain and ranges of these functions, the second one and the third one in particular. This one, domain and range here is all real numbers, and the domain and range here is restricted. So that can play an important part in if a function is one-to-one or not, and I'll show you an example of that right here. But first, let's go over how do you actually take the inverse of a function. So it's 4 quick and easy steps to take the inverse of a function. The first one is, again, to check to see if the function is one-to-one. If it is not one-to-one, then it has no inverse. If it is one-to-one, then you swap the x's and you swap the y's. Then you solve for y and simplify where needed. After that, whatever you have y equal to is the inverse of that function. So here's a couple of examples real quick. The first one is y equals 2x cubed plus 7. So how do we check to see if that is one-to-one? I just graphed it on my calculator, and here's the graph of it. And you can easily see that anywhere on that graph, you can put a horizontal line. It only touches one spot, so it is one-to-one. And so the next step is to switch the x's and to switch the y's. So we make that x equals 2y cubed plus 7. Subtract by 7 and divide by 2, and that equals y cubed. And then you raise each side to the 1/3 power, and that equals x minus 7 over 2 to the 1/3. You can simplify from there, but for this class, this is perfectly okay. And this right here is the actual inverse of this function. So in the second example, you have y equals sine of x. The domain here is all real numbers, so it is unrestricted. So you have this graph right here, there, and from there you can see it is not one-to-one because it'll touch a horizontal line will touch that graph in more than one places on multiple lines. So since it is not one-to-one, then it fails the horizontal line test, and therefore it has no inverse. The third one is y equals the square root of x plus 15. And, function one-to-one, let's think about it, is just all you do is take the square root of x function and you translate it by 15. So therefore it is one-to-one, and so therefore it does have an inverse. So then we swap the x's and the y's, and you get x equals the square root of y plus 15. Solving for y, you get y equals x minus 15 squared. You can expand that if you want to, but for this class, this is okay. So let's just have a quick review of today's lesson. Here it is. We reviewed one-to-one first, so that was the horizontal line test. And so then we went over inverses. So first you must check to make sure that function is one-to-one, and if it is one-to-one, then it does have an inverse. If it is not one-to-one, then it has no inverse. The next thing you do is to swap the x's and swap the y's. From there you solve for y and simplify where needed. Thank you. Be ready to discuss and have a quick quiz in the morning.